Here's a thought that might just rearrange your brain. If you could somehow travel to the very edge of our universe, you wouldn't hit a wall. There wouldn't be a sign that says, "You are now leaving the cosmos, please drive carefully." Instead, you would simply find yourself looking back at where you started. It's a cosmic mirage, a destination that recedes the moment you think you've arrived. This mind-bending concept challenges our most basic intuitions about space and boundaries. When Albert Einstein first proposed his theory of general relativity, he opened the door to understanding that space isn't just an empty void. It's a dynamic, four-dimensional entity called space-time. A massive object like the Sun creates a dip in space-time, and planets like Earth are simply following the straightest possible path through that curved space. Picture a balloon with little dots drawn all over its surface. As you inflate it, they all move away from each other. If you were a tiny ant walking on the surface of that balloon, you could walk forever and never find an edge. This idea of an expanding universe was confirmed by Edwin Hubble's groundbreaking observations in the 1920s. There's a big difference between the entire universe and the part of it we can see, the observable universe. And this part most certainly has an edge, not a physical wall, but a boundary in time. Think of it like being on a ship in the middle of a vast ocean. You can see out to the horizon, but that's not the edge of the ocean. The actual distance to the edge of our observable universe is about 46.5 billion light-years, making our cosmic bubble 93 billion light-years across. NASA's Wilkinson Microwave Anisotropy probe spent 9 years mapping the cosmic microwave background, the oldest light in the universe. These fluctuations are the seeds of all structure in the universe, a baby picture when it was only 380,000 years old. Planck's instruments were so sensitive they could detect temperature variations equivalent to measuring the heat of a rabbit on the moon from Earth. The results were clear. The universe is geometrically flat, obeying the rules of Euclidean geometry we learned in high school. When a cosmologist says the universe is flat, they're talking about geometry, not shape or topology. A flat sheet can be rolled into a cylinder. Connect the cylinder's ends to form a torus. The geometry is still flat, but an ant could walk in any direction and return to its starting point. It's a cosmic hall of mirrors, where light from distant galaxies could wrap around the entire universe to appear as multiple images. Our universe could be a three-dimensional hypertorus, geometrically flat but finite in volume. Scientists have searched for matching patterns in the cosmic microwave background, pairs of circles that would prove the universe wraps around itself. Jean-Pierre Luminet proposed a specific shape called Poincare dodecahedral space, where exiting one face means re-entering through the opposite face. So far the search has come up empty. No statistically significant detection of these repeating patterns has been found. If the universe is finite, it must be larger than our observable horizon, pushing the cosmic looping beyond what we can currently probe. A truly infinite universe leads to a staggering conclusion. Everything must repeat. Somewhere beyond our horizon is another Earth with an exact copy of you. In an infinite universe, there are infinitely many copies of you. Some living identical lives, others diverging based on quantum choices. Cosmic inflation suggests our Big Bang was just one bubble in an eternally inflating metaverse, spawning universes with different physical laws. Other universes might have stronger gravity, different speed of light, or more spatial dimensions, utterly unrecognizable and forever inaccessible. We find ourselves at the frontier of knowledge, peering into an abyss of cosmic uncertainty. We've learned the universe's edge is not a place but a boundary in time, our cosmic horizon, the limit of light. Science is like peeling an onion. We remove one layer only to find another, more complex layer beneath. Our most powerful telescopes have shown us the observable universe with breathtaking clarity, but also revealed a fundamental limit to our knowledge. We are inhabitants of a small, observable island in what could be an infinite cosmic ocean. We can measure our island with precision but can only speculate about the waters beyond. The universe's edge remains the greatest mystery. Not a physical barrier, but a profound limit on our understanding, forever beckoning us to look deeper, think harder, and imagine bigger.